So hello friends, in this video we are going to learn about single phase AC circuits with an inductive load. So let's say this is my source voltage, and if I connect with an inductor, then I am interested in how exactly my current will be related with a voltage. Let's say this is my instantaneous value of voltage. So to begin with, I am just considering I is Im sine omega t. This is the instantaneous value of current. Now there are two things. One is the EMF which is produced inside the inductor. So this EMF can be given as minus L di by dt. And if I relate this EMF which is produced inside the inductor, it is in the opposite direction, or will be the negative of the supply voltage. So will be given as minus L di by dt. So it is nothing but L di by dt. Now we are interested in to find the relationship between the supply voltage and the current. So thus V is L di by dt. So in short, I have to take differentiation of current. So Im sine omega t. So L, Im is the constant, that's why I am taking it out. Then the left, we will left with differentiation of sine omega t. So this is nothing but L Im. Differentiation of sine is nothing but cos omega t. And differentiation of omega t again with respect to time will gives us omega. This is omega L into Im into cos omega t. So this is the voltage. Now here this can be also given as VL Im sine omega t plus pi by 2. Okay, so if we just rewrite this equation, this is for voltage and one is for current, which is Im sine omega t. So current equation for the current was I equal to Im sine omega t, and equation for the voltage was, so V can be given as omega L into Im sine omega t plus pi by 2. So this is nothing but Vm. So V can be given as Vm sine omega t plus pi by 2. And what is Vm here? Vm is nothing but omega L into Im. So in order to find the reactance L, if we compare with the resistor, so what is R? R is nothing but V upon I. So Vm upon Im. This is the inductive reactance. So Vm upon Im is nothing but omega L. What is omega? 2 pi into frequency into L. So it means that if I increase this frequency, my XL would increase. Okay. And in order to draw its phasor diagram when omega t is equal to 0, so this current will have 0 degree, whereas the voltage V will have this Vm at 90 degree. So it in the phasor graph here 0 is there, 90 is there. So at omega t equal to omega t equal to 0, my Im would be here and voltage would be here. So this voltage, in short, this current is lagging to the voltage by an angle of 90 degree. Now this gives me information about phi, which is the angle between voltage and current. Now what is the power factor? So power factor is nothing cosine angle of the voltage and current. So this cosine angle of 90 will gives me 0. So this indicates that there is a 0 power factor. So what will be the active power? This is Vi cos phi. So the active power cos 90. So cos phi cos 90. So Vi cos 90 will be 0, and reactive power is Vi sin 90, because phi is 90, so will be Vi. So the apparent power is, which is P plus jq. P is 0 plus jq. So our apparent power is nothing but equal to reactive power. Okay, so this is all about inductive elements. Now if we want to plot it, so in order to plot it, let's say we are having two equations, basically I equal to Im sine omega t and V equal to Vm sine omega t plus pi by 2. So if we just try to plot it, and this is the waveform for current and voltage, so I would start with this Im. So I will at 0, the phasor would be 0, and Vm at omega t equal to 0, V is having peak value, right? So this will start with 1. So this will gradually increase like this. This is the current waveform, and voltage would start with positive peak. So it will have the waveform like this. So in short, current is lagging with respect to voltage by an angle of 90 degree. This is the 90-degree angle. This would be the waveform of voltage and current, and this is the theta omega t. So this is all about connecting inductor with a purely AC source. Thank you.